For this learning card, we're going to be looking at different graphical displays. We're going to be looking at different graphical displays for categorical data, and then we're also going to look at the different types of graphical displays you can make for quantitative data. There may be some some graphical displays that we don't put on this learning card, but this hits on most of them. First, let's kind of define categorical data. That is data that fits into a category. Most of the time, categorical data is not numbers. There are some exceptions to that, but most of the time, if the data that you are collecting is not a number, then you're collecting categorical data. Another name for categorical data is qualitative data. One type of graphical display that you can make out of qualitative or categorical data is a bar chart, sometimes called a bar graph. Some things to point out with a bar graph is that each one of these bars is independent of the others, and that's why there are spaces between those bars. Because we can put spaces between the bars, we could move these bars into any order we wanted to. So with a bar chart, just remember that there's spaces between the bars, and the bars can go in any order. Sometimes when you have a bar chart where the tallest bar is first and then it gets smaller and smaller and smaller, that is sometimes called a Pareto chart. So it has a special name. The other thing that we need to know is with a bar chart, we are comparing between different categories. Now, the other type of graphical display that we can make out of categorical data is a pie chart or a pie graph. When we look at a pie graph or a pie chart, we need to recognize that all of the pieces of the pie are going to add up to 100%. The other thing that we want to look at is that when we look at a pie graph, we are comparing to the whole. So we're looking at pieces of the pie that compare to the whole entire set of data. Before we move on to quantitative data, I want to talk a little bit more about categorical data and the different graphical displays. We don't have enough room on our learning card, but you could make a segmented bar chart as well, and you could also make a side-by-side bar chart out of categorical data. But you cannot make a pie chart or any of those types of bar charts out of quantitative data. So keep that in mind. These are two separate types of data, so they have a different set of graphs and charts that you can create from them. Now let's move on to quantitative data. Quantitative data is numerical data. So anytime you're collecting numbers, it is quantitative data. There are a couple of exceptions to that, and we've talked about that in class, but for the most part, if it's numbers, it's quantitative data. Now, quantitative data can be broken into two types of data, discrete and continuous. Quantitative data that is discrete is counted. Some examples of that might be the number of siblings that you have, or the number of cars that go through a stop sign during a 30-second period. If you are counting the data that you're collecting, that's discrete quantitative data. Now, continuous quantitative data is measured. So a person's weight, a person's height, the amount of water in a water bottle, that's continuous quantitative data. And from quantitative data, we can make different types of graphical displays. We're going to look at these right now. The first graphical display for quantitative data that we'll look at is a stem and leaf plot. Now, a stem and leaf plot looks like this. And you can see that this right here would be the tens, and then these would be the ones. And when you make a stem and leaf plot, it's also important that you have a key to your stem and leaf plot to provide some context. I squeezed the key in over here. There's not a lot of room, but what this tells me is the 0/3 equals 3 fish. And in this key, you can tell that we have a little bit of context, and we can tell what's happening here. So this would be 22 fish, 11 fish, 15 fish, 18 fish, 35 fish. So this gives you an idea of how you can use this stem and leaf plot. Now this stem and leaf plot over here that I'm about to create would be called a back-to-back stem and leaf plot. You can see in a back-to-back stem and leaf plot, you can compare two data sets at the same time that have similar values. Maybe one side is male, one side is female, maybe one side is seniors and one side is freshmen, but you can tell here that you can compare to with back-to-back. This would also need a key. I really don't have enough room on this card, but this would also need a key. A couple other things to fill in the blanks here, that it is better with a stem and leaf plot is best when you use small to medium sets of data. If you have a really large set of data, then you really don't want to try to make a stem and leaf plot out of it. Stem and leaf plots are better with small to medium sized sets of data. One of the other nice things about a stem and leaf plot is that it can show the shape of a distribution, the center of a distribution, and the spread of a distribution. Some of the other graphical displays don't show all of this, but a stem and leaf plot does. Sometimes with a stem and leaf plot, you can split the stem. So if you look at this example here, that is called a split stem and leaf plot. And notice that I've taken all of the single digit values and I've split them into 1 through 5 and then 7 through 9, or I should say 6 through 9. Same thing with the numbers in the teens, the lower half of the teens, the other half, the top half of the teens. With the 20s and 30s, I've done the same thing. So you can see that sometimes if you have a large amount of data, you can split the stems in half and still have a stem and leaf plot. All right, let's move over here to a dot plot. So this right here is called a dot plot. And dot plots and stem and leaf plots have something in common. And it's right here, if we fill in this blank, it says that dot plots and stem and leaf plots show all of the data points. You can see all of the data points in your data set in a stem and leaf plot. You can also see all of the data points in a dot plot that are a part of your distribution. It's also good that if you're trying to make a dot plot, it's best if you use small or medium-sized data sets. If you get hundreds and hundreds of data points, it's kind of difficult to make a dot plot or a stem and leaf plot out of that because it's just so many data points. If you had a large data set, you would want to use one of these other types of graphical displays. The graphical display that we have underneath of these dot plots is called a line plot. And usually a line plot is created out of data that involves time. Sometimes this is called a time series plot as well. Another type of graphical display for quantitative data is a histogram. In fact, histograms are very similar to bar charts. But with a histogram, you have quantitative data. Now, one thing I want you to notice is that with a histogram, the bars touch. And the reason why the bars touch in a histogram is because with quantitative data, there is an order to things. When one bar stops, the next bar starts up. With a bar chart, there's spaces because these bars can move around, and it doesn't matter what order they're in. But the order does matter with quantitative data, and therefore the bars of a histogram will touch. Another thing of note is that with these intervals, each one of these bars is a class or an interval. The interval size or the class size or the bin size, sometimes it's called, must be equal. You can't have one bar that stretches a range of 10 and another bar that stretches a range of 4. They have to be equal. Histograms are great for medium-sized data sets or large data sets. A histogram also gives you a really good look at socks, or you can describe a histogram well you can describe your distribution using a histogram because it shows you the shape of the distribution. This would be bell-shaped and symmetric. It shows you any outliers or unusual features. You can describe the center of the distribution using a histogram, whether it's the mean or the median, and then the spread of a distribution can also be described with a histogram. So a histogram is really nice and is used many times to ask you to use socks in order to describe a distribution. A box plot is another way to display quantitative data. And with a box plot, it's great for any size data set that you have, small, medium, or large. A box plot can also give you an idea of the shape, any outliers or unusual features. You can see outliers right here in this box plot. It can help describe the center and the spread of a distribution. The center, if you use a box plot, the center of the distribution would be the median here, and the spread that you would want to use would be the interquartile range, which goes from Q1 to Q2, or the first quartile to the third quartile. I said Q2, I should have said Q3, the third quartile. The median, by the way, is the second quartile as well. We're going to have another learning card on just the 5-number summary and box plots, and we'll dig into a little bit more detail here. The last graphical display that we have here for quantitative data is called an ogive, O-G-I-V-E. That's pronounced ogive, not ogive, but an ogive. And we don't see ogives very often. I have seen very few ogives on AP tests. But an ogive, what it does is it takes and it uses cumulative data, or it accumulates the data as you go. So here we're starting at 0%. The next dot is at about 5, maybe 3%. The next dot is at about 6%. But what it's doing is it's adding and adding and adding the data as you go further on the horizontal axis. You're adding the percent of the data as you go until you get to the very top, which would be 100% of the data. So an ogive is useful, but we don't see it very often. And that is your learning card for graphical displays. Have fun in your stats class.